assignments, doubts, exams. We have got you back. EduPlanner make every chapter easy to understand. Stay tuned, learn more, grow with us.
Here, because the particle has zero speed at x not equal to zero, then the partition at that momentarily at being at rest momentarily essentially would be its maximum displacement. So we can say that the initial position is equaling its maximum displacement or its amplitude, and this would be 0.37 meters. So we can then infer that from this phase constant, phi is going to be equal to 0, and that would be from equation 15.2. Now, also, the period f is given, or the frequency f is given 0.25 hertz, and we have that omega, the angular frequency, is giving us 2 pi times f, so this would be equal to pi over 2 radians per second. And so we can then say for part A, the period is simply the reciprocal of the frequency. This would be 1 over 0.25 hertz, and this would be giving us 4 seconds. For part B, we already know the angular frequency is going to be equal to pi over 2 radians per second. For part C, the amplitude would be the maximum displacement. This would be equal to 0.37 meters. For part D, from equation 15.3, we can then say that the x position would be equal to 0.37 0.37 centimeters. I said that this was centimeters here. My apologies. So this is centimeters and not meters. My apologies. But the equation from 15.3, tailoring our specific givens, this would be x position would equal to 0.37 centimeters times cosine of pi times t over 2, and then the phase constant is, of course, 0, so that term is eliminated. For part E, the derivative of x would be equal to v, so v is equaling dx with respect to t, and this would be equal to negative 0.37 centimeters per second multiplied by pi over 2 times sine of pi over 2 times t, and we can then say that v, simplifying, would be negative 0.58 centimeters per second multiplied by sine of pi t over 2. This would be our essentially our equation for speed, or linear speed. For part F, we then know that our maximum speed would be negative 0.58 centimeters per second, and this is from simply analyzing our answer to part E. For part G, the acceleration amplitude A sub m would be equal to omega squared times the amplitude m. This would be equal to pi over 2 radians per second quantity squared multiplied by 0.37 centimeters. And so this would be giving us 0.91 centimeters per second squared. For part H, making sure that our calculator is in radians mode, we're going to set x equaling 0.37 cosine of pi times 3.0 seconds, essentially, divided by 2. Then we're going to set this equal to 0, and then rather finding this pi times 0.0, this would give us pi over 2. Cosine of 3 pi over 2 is going to be 0, which means that the x position at t equaling 3.0 seconds is going to be equal to 0 meters. And again, set this equal to radians. set the calculator equal to radians mode. And then finally, for part I, keep the calculator in radians mode. We can then say that v at t equals 3.0 seconds. This would be giving us negative 0.58 centimeters per second multiplied by sine of 3 pi over 2. Sine of 3 pi over 2 is going to be negative 1. So negative 1 times negative 0.58, this would be positive 0.58 centimeters per second. This would be our answer for part I, our answer for part H, and our answer for part G. That is the end of the solution. Thank you for watching.